A device which is used most often for security is a firewall, and a firewall works at the network and transport layer level. The firewall will typically run on a router, and it filters for the source and destination IP addresses. It can also filter for the TCP sockets. It can filter in either way, either incoming traffic or outgoing traffic. So we can build up a model which will secure traffic for both its source and its destination. With firewalls, we can set up proxy servers so that the only communication that we can have for certain applications will only be allowed through the network or the firewall if it is destined for a proxy server. The most secure system that we can have is built around a gateway and two firewalls. In this case, the only traffic that is allowed through firewall B is traffic destined for the gateway. The gateway then checks the security information, such as is the person allowed to get out of the network, and if they are, they will forward it through the firewall A onto the internet. Firewall A will only allow communications out from the gateway or to the gateway. In this type of system, it is impossible for someone on the internet to communicate with either Net 1 or Net 2. Typically, we don't just run a firewall at the boundary of the organization. As we've said many times, there is only typically one gateway out of the organization. In this way, if we have only one gateway, then that is the place that we can implement our security policies for the whole of the network. So the main firewall defines the security policies for the complete network. For example, at Napier, it is not possible to run net metering because the main firewall blocks one or two of the ports. It is not possible to ping or to traceroute. And that is a security policy for the whole of Napier. We can then refine the security policies for each of the sites or each of the work groups within inside the organization. Some parts of the organization, such as the finance department, might have a very strong closed firewall that doesn't allow people to get across it. Others might be more open. So it is important to define the security policy for each of the work groups within inside the organization. For example, at Napier, on the staff network, it is not possible for staff to run web servers because the firewall blocks any web traffic to them. Along with this, it is important to have an audit monitor on the network. If breaches occur, then it is important for the organization to trace back the steps that occurred for the breach to occur so that they can make steps against it in the future. With the increase in mobility and the increase in home working and also networks that span across countries and large networks, there is a requirement to use the internet as a communications channel. At one time, organizations used lease lines. Lease lines were seen to be extremely secure. Unfortunately, they aren't. It is possible for anyone or many people to tap into the communications of a lease line. It is also much cheaper to use the internet as a communication channel between two sites or from a home user and an office network. Thus, we can have firewalls at either side of our network. And then what we can do is that we can build in encryption into the routers. In the same way that we did with public key encryption, the routers generate two keys and pass each other their public key. They then encrypt the data so that the encrypted data on the internet cannot be decrypted. The only device that can decrypt it is the destination firewall. So firewalls will filter data that's coming into or out of our network or work groups. It can filter on the source or the destination address, and we can refine it so that we look at certain parts of the IP address. For example, on the Napier network, 146.176 defines Napier. We could make it that anything that traffic was allowed out from the 161 or 162 network, and everything else would be disbarred. So we can look at each part of the IP address and filter with it. We can also filter on the source and the destination port. Typical ports that we looked at in transport were port 80 for web traffic, port 21 for FTP, port 23 for telnet, port 25 for email. So we can filter on those ports also. If we want to stop any FTP or telnet on our site, then the firewall will be set up to block every occurrence of port 21 and port 23. So the firewall is implemented on a router and will filter in both the ingoing and outgoing directions. Each port of the router can perform this routing operation. So what we can have is that we can have localized security policies for our own work groups. So each router can implement its own security, and we can take that down to the very lowest level in that each user has their own security policy. Typically, firewalls are implemented as a hardware device because they can quickly route information in and out. But it is also possible to run a firewall on a user's own PC. In that way, all communications that's coming in and out are checked against some security policy. So then what we have is that we have the main gateway out of the organization as the main security policy for the whole of the organization.